Well, hi everybody. Thank you for joining this November's webinar for IDEA StatiCa. This one will be covering some of the new topics on the 24.1 release that happened last month, so it should be an interesting one, especially if you're looking to pick up some new tips and sort of tricks about the software and some cool changes that we've done with Checkbot and linking new software into IDEA. All right, so looking at the agenda today, Andrea is going to lead us through some of the new changes in Checkbot, like I mentioned. So we'll look at nodes, dynamic grouping, and batch design, so designing multiple connections at once there. And then Johan will take us through a bunch of different items within the connection app and different improvements, of which there are quite a few there. So we'll do some sort of presentation and then some sort of actual working in the software as well. So we'll get a good.
Okay, so I would like to start with the available supported integrations that we have with IDEA StatiCa, like to send information to IDEA StatiCa. If you haven't explored the integrated workflows, please visit our website to explore how to share information between these applications that you are seeing on the screen and IDEA StatiCa. You'll start saving time right away. Like instead of modeling everything from scratch, you can just start sending information to IDEA StatiCa and avoid manual inputs. So in that handout, I have all those links that you're seeing there. You can click over them and you will see more information about it. So because I'm going to talk about Checkbot, I'd like to start with the background of what is Checkbot. So Checkbot is our application that translates information from the mentioned applications that I showed before into IDEA StatiCa. So we have some years using Checkbot to transfer structures from analysis applications into the IDEA StatiCa world. So what's new? In this structure, you can see that most of the connections will be similar, right? So with the objective of saving time, we developed a dynamic node grouping. So what is this? The dynamic grouping is an automatic action that Checkbot does once it imports the model. From the model joins, it will arrange the nodes by typology, which is defined by number of members and its orientation, right? And then the arrangements are the second level of groups, which are defined from the typologies, right? And they are defined by cross-section type. You can see some examples in this slide, like in the first typology, we have 2 beams to 1 column, and then from that typology, we have 3 arrangements, which are defined by different cross sections, and then the same for typology 2 and typology 3. So this is the automatic grouping that Checkbot is doing once you import a structure. All right, and even if you have a Checkbot already, like a Checkbot model created already, and then you open it in this new version, you will see how this is done, like in your structure. All right, so then there is a third level, which we call user groups. Those can be defined from the arrangements by the user. And then each arrangement can have different groups as the user decides. So you can see in this example here, in this last column that we have here, that we have typology number 2, then we have arrangements, and then from these arrangements, then we have the third level that's called group 1 and group 2. So the user will decide which joins will be in each group, right? Then the groups that the user is creating here lead us to the batch design. So let's see the process in the following slide. So the user will define the groups of joins from the arrangements, right? Then each group will have a reference connection. That connection will be the master item. After designing it, you close that item and then click on Calculate All. This will instruct the software to copy the master connection to all the joins in the group and then analyze them. So let's review this process in a video, right? So here you can see Then we have typology number 1, and then arrangement 1-1. And in this video, I am showing the arrangement 1-1, and that's basically base plates, right? This arrangement has only one member, right? Because it's the base plate, and this arrangement is it's only for round hollow sections. We have another arrangement for base plates that was for rectangular hollow sections. So it detects, the cross section. Then you can always right-click over the arrangement and select all the connections within that arrangement, okay? From there, we can create that group. So you will see here, once we select the connections, you can right-click over that group, select all, and then create group. You'll have that option there, okay, once you right-click over there. Then that group 1, you can rename it. You can put your own name. And then you can see there is a connection underlined. That's our reference connection. You will open that connection. Then IDEA StatiCa Connection will be open. You will design either from starting from scratch, from operations, or from connection library. That's up to you. In this case, I'm using a base plate operation, right? I am defining all the details here, thicknesses, welds, all details for this connection. Then I save this connection. Once I finish the design, I save this connection. Close this item, right? Go back to the main screen. Click over the group 1, and then hit calculate all. This will again instruct the software to copy that connection in all the groups and then run the analysis for all of them. You will see the details of this analysis in the right side with the status of all the connections. But the good thing of this is that you are not just using the worst case, let's say, load combinations for only one connection. We're running the analysis for each of their critical loads, right? So basically, we're not over designing because we are using its own critical load combinations. And then if some of the connections is failing, you can just open that connection and redesign the connection, or maybe optimize the connection or reinforce the connection, but you will have all the details there to take that decision. But again, this is saving a lot of time because then you don't have to open one by one and apply a connection, right? So that's the new dynamic grouping and batch design. As I said, if you already have a Checkbot file, you can open it in this new version, and then you will see this automatic grouping in your previous model. Okay. So now let's jump into the connection application new stuff. So I'll start with parametric templates for connection app. Probably you have heard about parametric templates in our new version, but what is this? In few words, parametric templates are connection templates that have been coded with common terms. For the AISC users, we have done 5 of them based on Design Guide 39 and the AISC manual terminology. But in total, in the whole application, we have 50 new parametric templates, okay? So here's an example of how this template is implemented. Let me show you this small video. If you see, here we have some parameters that you haven't seen before, like gauge, and then these questions of how many rows of volts above the top flange, how many rows of volts below the top flange. You can activate the top stiffener. So these parameters were coded in this template, okay, with common terms for AISC users, right? And as you can see, every time you change something in these parameters, the model change, right? That is because we have coded, or we have linked the parameters to to the operations, right? So with these templates, we can create many possibilities, like in this case, there's 6 configurations from Design Guide 39, just by using these parameters, okay? So as I said, we have 50 new templates in the application, so how to use them? First of all, I'll recommend that you start with this beam to column type of joint, right? So you need to set up a blank geometry. The next step will be to go to the connection library options that we have in connection application and click over propose. The third step will be to activate the parametric filter in this window, on the connection library window. You can see it here. And after that, you select the template. You can see the small p, that means this is a parametric template. You select the template, then click OK. Then that template will be applied to the connection, right? And then to input the parameters or to see the parameters, you'll click over operations, okay? If you click over operations, you will see the parameters here, and then you can input those values, and then you will see how the connection or the design is changing when you change these values here, right? Also, you will see that this is gray out. So we're graying out this because the intention of this template is that you control the connection from the operations line, right? Anyway, we have the way to explode this if you just want to change this, but you're breaking the link from these parameters. And that is not the objective, right? So we have 50 of them already in the application that you can go ahead and explore them, right? But also there is a way to build your own parametric templates. So how to build them, how to relate these parameters to the operations. Here we have a template. This is like a more advanced template, but today I'll do a quick example. I'll do a shear tab template. This is very simple. So the shear tab thickness will be equal to the beam weft thickness, right? So every time you change the beam, we'll read the weft thickness, and that will be the thickness of the shear tab. The user will input the number of wall rows and the number of wall columns, okay? And then the default values will be the top offset from the top flange, the gap between the beam and the column, and the bolt spacing will be 3 inches. You can see that I am putting here meters. Why? The software behind the scenes is always working in metric, right? So we need to input this parameter or this default value in the parameters in metric version. You'll see that in the example, okay? So to start, you need to just go to the new screen, to new connection. Then you go to preferences, and you need to activate developer mode, okay? So you can see that in this case it's active already. You save that, and then you close this window. Then you go to a new connection, and you will set up the connection as if you were seeing the final result, right? So in this case, I'll use a shear tab template here. Well, a blank connection. Let's start with a blank connection here. We hit create project, and then the connection will open. All right, so for this one, I'll change the weft flange to a 14. And then say OK. Then I'll add a new operation that will be a shear tab. Okay, and let's input the default values. For instance, the gap, as we said, it's going to be 0.5 inches. I'll use dimensions top of seal. The top offset will be -1 inch, right? And then that's it. Also, I'll set up the weld size to be 5/16. what we're going to code is going to be the transverse spacing and the longitudinal spacing. In this case, we say 3 inches, and then if we want more bolts, we can use the asterisk and say 3 more spacings, right? So we have 3 inches multiplied by the spacings we want. And then for the longitudinal spacing, we can say 3 inches, and that will be the space between 2 columns, okay? So in this case, what we want to code is the user input that will tell you how many rows of bolts and how many columns of bolts the user wants for this shear tab. So to do that, we go now into the developer mode, all right? And then we start setting up the parameters. So in this case, the first parameter, I'll create a new parameter. And you can see that here we have this P1 parameter. You can change the name of that and then the description. This first parameter, I'll ask the software to pull the beam weft thickness, right? And then I can put here the expression. This will be something similar to an Excel expression, right? Or a coding expression. And then for that, we have this reference guide. You can go to this reference guide every time you need it, right? And then you can look for all the functions and operations, right, to code your template. Anyway, I'll go for the property function to get the weft thickness. So you can copy this. I'll Control-C this, go to my connection, paste this expression here, and that will get the beam plate thickness, the web. Right? I need to select what is the unit of this value. In this case, I scroll down to plate thickness. So you can see that it's pulling the 7/16, that is this thickness of this web, right? Now the next parameter will be me asking the user how many bolt rows they want, right? The default expression will be 2, right? And the type of value is going to be generic, but this will be a visible parameter. The same for column bolts columns, right? And I'll use 2. And this will be visible here, okay? Now, because remember that in the fin plate operation, we ask for the spacing, not the number of rows of bolts. So I'll do this calculation internally. So that will be bolts input multiplier. So that will be P2 minus 1, right? And the next one will be bolt column multiplier. So that will be P3 minus 1. So you can see the value here. So it's subtracting 2, the expression minus 1. So that's 1 here, right? If I change this to 3, this will be 2. And then I want to set up the transfer bolt input. So how I'll do that? So I add a new parameter. So this will be the transfer spacing that I'll link to the fin plate operation. Transfer bolts bolt input. All right, that's the description I'm giving to it. And to do this, I need an expression that's concat. So that will combine number values with 3 inches. That will be the spacing, right? Which is going to be the default. So I am going to use this example. So I'll copy this and paste it here in the expression. Okay. So for this, I'll use apostrophe, the 3 inches value, which is going to be in metric, close the apostrophe, comma, apostrophe, asterisk, apostrophe, comma, and then that'll be P4 then, which is going to be the multiplier, right? Okay, let's see if I am missing something here. There you go. It was capital letter. So this will be the value I'm going to link into the transfer spacing bolt input. Again, I'm going to create a new one. So that will be the transfer. I'm going to use now the longitudinal. Well, I'm going to set up the longitudinal spacing. Bolt input, right? I'm going to copy this. And instead of P4, this will be P5, right? Now that I have these values set up, now I can go to the Model Properties tab. And this is where I am going to link the fin plate operation inputs with the parameters that I coded, right? So the thickness, which is the thickness from FP1, I'll apply that. That'll be related to parameter P1, right? And then say OK. And then I add a new property link. And I scroll down here to look for the transfer spacing, which is here. I apply, and then the longitudinal spacing, and then I apply. I close this and set up the correct parameters. So in this case, it's transfer spacing is going to be equal to P6. Longitudinal spacing is going to be equal to P7. Say OK. And now if we go back to the Design tab here, you can see if we click over the operations, now we have these parameters over here. We can start testing this, like all rows will be maybe 1, just to test it. And you can see that's changed automatically. All columns, we can say just 2, and that's automatically set up. So we can just test it like that, and you see that it's working, right? Now, how we'll share this template with our colleagues. So you can go and go ahead and hit publish. And then you save this template with your name here, well, a custom name here. Save it either in your personal or company design set. And you keep this parametric option active. And then you just click publish. And then this will be available for users. So they will see this operations parameter over here. All right. So that was like a quick and easy example. But we have more tutorials in our website. This is for flush moment end plates. These are interesting. And I have the template over that in that tutorial. So feel free to explore this tutorial. It's fun to do. So why to build these parametric templates? So what are the benefits of doing this? First of all, maybe you have custom company connections or common company details. So you can start creating this parametric templates, and then you don't have to start from scratch every time. You can use these templates every time you have this common details like shear tabs, double angle, clip angle, simple connections, right? The second benefit is that we have these smart templates. So as I show you, every time you change a parameter, then this is coded, right? You can code your values here, and it's related to properties from the model or calculations that you did here in this parameters table. And finally, the third benefit is that you can avoid the learning modeling curve or modeling learning curve for simple connections for some users in your company. Like there are some users that they are not doing probably the very complex designs, and they want to use IDEA StatiCa for simple shear tabs. Well, they can just use these parametric templates and input these simple parameters that they don't have to learn how to use the operations. Maybe they just go ahead and change these values in this template, in these templates. So those are the common use cases that we have seen. So feel free to start looking at those. And that's the end of my part of the presentation. Now Johan is going to share the screen.
Sounds good. Thank you, Andrea. So we'll go ahead and talk about the weld capacity estimation feature within IDEA StatiCa. It is a new feature that was released within version 24.1, and it's as a measure to offer more insights to low weld loading conditions. As part of the feature, it offers the capacity estimation of the entire weld length. And this capacity estimation is driven through a machine learning estimation model. Before we dive into the learning model, let's first talk about the new feature and why it was released. So basically, during lower weld loading conditions, there can be some stress concentrations that occur along the weld. For example, if we look at image 1, on the bottom for the stress distribution, you can see that there is an uneven distribution. And for these reasons, the stress values at lower load levels should not be used directly to determine the capacity of the weld. Now, as the loading increases in the weld, these peaks are gradually smoothed out and the stress is evenly distributed along the length of the weld, which can be seen in the second image at the bottom for the equivalent stress. As you can see, when we compare example 1 to example 2, those stress distributions are completely different. So traditionally, this estimation was not available, and only the utilization at the most stressed element in the entire weld length was used for the code check. So as you can see in the first image, a 75% on the utilization check only corresponds to about 50% of the entire weld capacity. This can sometimes lead to false assumptions, and this is why IDEA StatiCa has now added the weld capacity estimation feature. This additional piece of information has been requested by many before, and it's basically now here to provide those additional insights to our users. So basically, in order to obtain these type of results, a machine learning model was used along with some convolution filters that were used to obtain the information about the stress distribution on many different sample models. These results then served as an input to a neural network that our developers use to predict the weld capacity. Now, during the evaluation process to predict the prediction success of the model was able to achieve a below 5% standard deviation. So this just goes to show how well calibrated this model is to be able to predict these types of weld capacities. Now, along with this weld, now users are able to optimize their connections while being able to provide better results and obtain more knowledge along the way. Now, this new feature is already available within the version 24.1 as mentioned, and will always be a part of your results for the weld checks. As you can see, you not only have your regular utilization check, your UT, but you will now have UTC, which will be the weld capacity estimation. All right, and so now after discussing the weld capacity estimation, we can move on to the live demo where we will present some more of these features. Some of those features involve the measuring tool, the operations for multiselect and multiedit, how you can take advantage of those. We'll also look into the project tab, how you will be able to move around and adjust the order of multiple items in one file. And we'll also look at new default material properties that you can adjust before you start your project, as well as the new cross-section database. So if we'll go ahead and exit this presentation. So first, one of the first features that have been added were the measure tool. In order to locate this measure tool, it's very simple. It will be located in the visualization window. And on the icons, it will be the very first one from the left. So if I hover over this symbol, you can see that the types of things that you can measure will be the vertices, edges, and surfaces. Now the distance that it will provide for you will be the shortest distance, and afterwards it will provide you the global coordinates of that distance. So that will be the X, Y, and Z if available. So to activate it, just click on that icon. And this measuring tool is very useful sometimes whenever you want to create some dimension inputs or when you want to verify. So let's say we want to know the top of steel for this cleat. All we have to do is just click on this surface and compare it to the surface of this angle. As you can see now, we can verify that this is a 2-inch spacing on this top of steel. Other useful methods can be for measuring distances or clearances. If we look at this, we want to see the clearance of this member to the other member. All we have to do is click on the edge and maybe a point on this member. And then we can see some distances. You can also look into some of the complete weld lengths that can help you. You will not be able to directly look at the weld lengths, but you can direct yourself with some cut operations. In this case, if we want to see this notch on the member for the length, we can look at one corner to the other corner and measure that length. This will be very useful whenever you're working with your operations and you're looking into putting some dimensions. You can easily measure these changes and input those values into your operations. Now, to exit out of this measuring tool, you don't have to go back and click on the measuring tool to exit. You can just click escape and you're out of it so that you can start rotating and moving your model as you need to. Now, the second feature that we have come up with is the operations multiselect and multi-edit. This operation is very useful whenever you have two similar operations that might need some of their parameters to be changed. So let's go ahead and take a look at it. So if, let's say we have this connection and we want to adjust maybe the thickness of these two gusset plates, maybe the material properties of them. Instead of going one by one, we can now multi-select all these operations. Just hold down the control button and click on the different operations. As you start clicking, these operations, the parameters that are similar will be shown on the right, and you will be able to adjust those. So in this case, let's say we want to adjust the material from A572 to 836, we can do that as well. Maybe we want to reduce that thickness from 1 inch for both of them to 3/4. We can also do that as well. If we want to adjust the weld of both of these gusset plates for either the plate connecting to the member or the member connecting to the plate, we can adjust that as well. Other possible things that you can do is maybe if you are not using some operations, you can multi-select all these operations. Even if they don't have anything in common, you can always copy and delete. Now, the way that this multi-selection works is you will be able to select only items within the same section type. So if you select items here under operations, you will have options, at least the copy and delete option. But if you try to combine them, let's say an operation and a load effect, you will not have any editable things and you will be shown that you have multiple items. So this is just a way to keep order in these multi-selections, so just ensure to stay within the same section types for the items. All right. If we go on to the third release of this version, will be in the project tab. To access it, all you have to do is go back to the project tab. And this is intended for whenever you're working with multiple projects in one file. Typically, we've heard some cases of some users where they're creating their connections and maybe the order of these connections is not what they wanted as the final output, or maybe they were putting in a wrong order and they just want to adjust it. Previously, this was not available, but now all you have to do is just click and drag it to whatever location you want to adjust those connections. So if you want to rearrange the order from last to first or first to last or any other order that you would like, you can just drag and drop. Now, as you can see, another improvement from IDEA StatiCa is that the application speed of our newer version is a lot faster than the previous ones. You are now able to change between connections, between operations or items a lot faster than what you would otherwise do beforehand. Another thing that might not have seen visible in the application is that here in the project tab, you can now also calculate all of your connections and select whether you want to add buckling or not to those analysis checks. So if you want to adjust the order of these connections, it's as easy as click and drag. Now for the other two additional features that we have within IDEA StatiCa, these are more whenever you're opening a new project, at least the very first one, and then the other one, which involves the database. The other feature, which is the default materials, can be obtained whenever you're opening a new project and you're directed to the connection wizard. Let's say you're in this connection wizard, you're looking at a certain model. You've already clicked on your class, geometry, connection for your design options. The last part, as part of your parameters, the new features are that we now have more parameter options for more sections. So we have parameter options for open roll, plates, angle, channels, and hollow structural sections. So all you have to do if you want to adjust these properties is just click on this icon and then select it to whatever you would like. Now, if you adjust these parameters within this window, these parameters will be affected for the existing model. So if you would just want to adjust them for this model, they will be adjusted, but if you want to keep a separate default, you will have to change them within the project settings. So let's say we want to have these adjustments and make those default. If I click on these, click create project, I can open my project. Then I can go to the project settings. And here under the project settings for the materials and materials defaults, I can load whatever my material defaults need to be and then click save as defaults. So once you save them as defaults, any other project that you open within Connection Wizard will have those defaults. Maybe you can use these for your most common material properties, but if you ever have those other custom projects that might need different properties, you can always adjust those for that existing project. And another thing that has been released within IDEA StatiCa, which is very useful for most of our users, is that we now have the most updated database from the AISC cross-section, which is version 16. So if you go to any other member, let's say you want to click on this member, access those different cross-sections, if you click on the plus icon, and let's say we select an I-beam, and we want to look at the geometry. As you might already know, we have multiple different international databases available within our options. But if you start typing, let's say a W10 by 22, the one that we currently have, as you can see, now we already have this library. You might already know that as you start typing these options, your libraries are filtered out based on the size that you're looking for. So in this case, since we're looking for a W10 by 22, we can see that we have the latest library. It not only applies for the I-beams, but if you look into other cross sections, all of those have also been added. If we're looking at some HSS connections, we can also find that we have the latest database as well. So with this, we basically covered some of the other smaller improvements, which are the measuring tool. Again, you can find this measuring tool on the very first symbol from the left. Just click on it, select either your corner, edges, or surfaces to be able to measure different distances. To exit, just press the escape button and you will be able to go back to normal. The second one was the multi-select, multi-edit operations, meaning you can multi-select different operations. If they have similar parameters in common, you will be able to adjust them. In this case, for the Weld operations, again, you can adjust the size, of it, which will be useful. Next one was the project tab. In case you have multiple items, you will be able to arrange them in different order as you like. And the last two were the default material properties that you can set them up as templates for new projects and our new database, version 16 from the AISC cross sections. So with this, this will cover basically all of the different feature releases from version 24.1. And I believe we can move on to the Q&A for the rest of the presentation.
Yeah, thanks, Johan and Andrea. That was great. Good to hear all the cool new things that are happening. And yeah, now we have some time for Q&A. We didn't have too many questions come in, so if you're sitting there and you have a question, feel free to add in a question or two. One question that came in that was sort of a two-part question, but I think part of it we can answer right now. Had to do with the user asking about Checkbot and working with a detailer who didn't have IDEA StatiCa, and curious how they can get a Checkbot file and how that process works, when the detailer doesn't have IDEA StatiCa. Andrea or Johan, could you address that one?
Yep, I can jump into that one. All right, so yeah, the way, well, we have done like a webinar about that process, and the best way is that the detailer uses our basic account, so they can use Checkbot. So they use Checkbot, let's say, for free. So the detailer can import their, in this case, SDS2 or Tekla model into IDEA StatiCa Checkbot, and then that Checkbot file can be sent to the connection designer or the engineer, right? So they can get that connection right away. And then the other thing that I wanted to add is that, Johan, can you put the slide where to download IDEA StatiCa 24.1, just like a reminder? So
There we go.
there you go. Yeah. So you can always go to ideastatica.com, product downloads, and you will find the current version over there. You just click download and you can install it right away, right? Right, do we have more questions, Jason?
Yeah, we had a couple more pop in here.
Okay.
Let's see. So one question says, can you make parameters for non-standard connections, or is it just for adding, plates or stiffeners? So I think the general question is more like, how complex can you get with parameters, or what's the bounds?
Yeah, no, I think you can go as further as you want. So we have, you can link the parameters to different operations in the model. So even for the members, so you can set up the distance, the position of the force. Yeah, so I recommend, I highly recommend that you go to that parameter developer tab, and then to the parameters, and then the linking, so you can see what can be related to what, and go to that also tutorial that we have. But yeah, you can link to many different options there.
Okay, perfect. And then another one that came through was, the question is for the multi-select function. Are you able to edit different operations, or does it have to be the same operation type?
You can edit different operations as long as they have at least a parameter in common, might be the weld or thickness. You will be able to edit different operations.
I think he's asking about the bolts. So probably yes, if they have a common value, then they'll be, you can change that in multiple operations.
Correct.
Yeah. Okay, perfect. Let's see here. Are there any other ones?
I see that someone is asking about Checkbot for MBS. Can you bring the slide with the applications that we linked with?
Yes, 1 second.
Yeah. So also in the handout, we have that. that slide where you can see what are the available links that we have. All right.
Perfect. Okay, well, I think that probably covers us there. There's a few other questions that popped in there that we'll follow up with you guys directly. Don't forget, if you want to get the handouts from today, you can download them here on the right side of your screen. We'll also post the webinar video and all the info on the website here in a few days under the webinars section there. And this will be our last webinar of the year. We'll take a break in December just for 1 month, then get back into it in January. So keep an eye out for our first webinar in 2025. That'll be in January. And other than that, thanks, Johan and Andrea. Everyone else have a great holiday season and happy designing and getting all your projects done before the end of the year here. So thanks everyone for attending, and have a good one.
Thank you. Bye.
Bye-bye.